Hello everyone. In this video we are going to work on a real-world situation, which is making a decision between flying or driving to a venue, let's say workshop, conference, anything in another town. And here you are going to have some important factors that you can get from the user or make some assumptions about them, and then you write a MATLAB code that will help the user decide whether flying is the option to go or driving. And the ultimate decision will end up with price and time. Okay, so all of these factors that you see I have listed here, first of all, these are not all the factors, these are just some of the factors. And they ultimately end up calculating the total time and the total cost for each one of the options of flying and driving, and then we'll make a decision. So the most important thing, of course, is the time you have to get to the destination. So that's the ultimate factor. If you really have to go there and be there at a specific time, and that time is quite close to the current day, let's say it's tomorrow or maybe even this afternoon or 2 days from now, it is very, very important that you make sure that the total driving or flying time is not more than the total time you have. Once that is taken care of, now you look at the price and maybe then you can decide. So here we work with, as I said, time and cost, which are tangible parameters, because there is, of course, the ease of transportation, the watching of sceneries, and so many other things that it's not easy to materialize and put a value at. So we'll try to stick to material parameters and inputs. So like what? Like the minimum total flight time that you have, and this one actually includes the connections and the layovers, right? So you have to consider the whole thing and how much time is the total thing that you need to go from your location to the destination, the price for the flight ticket, the airport commute time. So how much time do you need from your location to go to the next to the airport next to you, and then once you arrive in the destination, how much time you need to go from the airport at the destination to the venue location. The transportation cost in that destination from and to airport, right? So once you arrive there, you have to take a taxi, let's say, or rent a car. So the minimum cost of that is what you need to go from airport to that venue and then back from venue to airport to come back. Then for driving, you have the driving distance, of course, the average driving speed that you can have, which is highway plus streets, the gas price, the gas mileage of your car, the fuel tank capacity of your car, which determines how many times you have to stop and fill it, the cost of hotel per night, the price per meal, and so on and so forth. Okay, so let's go ahead and get these numbers from the user, plus probably some other assumptions we have to make, and then write a MATLAB code to help the user decide. So here we go ahead and we start getting the numbers. So the first section is going to be user inputs and assumptions. So here we go. And I assume that here the units are basically miles for distance, hours for time, dollar for the cost, and gallons for the gas. Okay, so we can ask the user to enter all of those parameters that we discussed. We can ask the user to enter them, and we can use the command input, right? So here I'm gonna type all of them for you here. Okay, so you see here I have entered all of them. From the time you have left, to flight time, to flight price, airport, commute time, transport cost, from and to the airport in destination, total driving distance, excuse me, average driving distance, gas price per gallon, gas mileage of the car, fuel tank capacity of the car, and the hotel cost and the meal cost. Okay, so these you can get from the user, and then here you can basically ask more from the user, or you can make some assumptions here that, for example, every so many miles basically you have to stop for sleep in a hotel, or every so many miles you have to have a meal, right? So you can make those assumptions as well. So if I do that, let's say we say hotel frequency or sleep frequency, although it's not really frequency, it's the period, but let's say every 12 hours of total drive in the car, including meal and fueling. After 12 hours of total of that, you need to sleep in a hotel, and then meal frequency is going to be, or I can say sleep, let me call it period, because frequency is not really the proper word. So I say every, let's say, 5 hours of the drive time, you need to have a meal. Okay, so these are all of those assumptions. Now here you do what? Here you do the calculations. So as I said, you need time and cost for each one of the options. So for flight, it's not as hard. So total flight time. The total flight time that you need is equal to the time that is for layovers and connections, correct? Plus the time that you need to drive to the airport next to you, and then from the destination airport to the venue, which we call it airport commute time, right? So once you get these two from the user, you can add them, and that is the total flight time. And then we can have the total flight cost. For the total flight cost, here we can, if we want to, we can add a meal to the flight, or we can say, well, if the flight is short, there will be no meal. If the flight is long, and you can expect that they give you some food in the airplane, so let's not add that to the total flight cost, and just say the total flight cost is actually the price that you pay for the ticket, right? So we say flight cost total is the price of the ticket plus the price you pay for transportation from and to the airport in the destination. Okay, so that's not really something hard to do. But now when you come to total time and cost of driving, it is a little bit more involved. Okay, you have to do more calculations. Okay, so for the drive time, first we assume that you don't stop at all. You just directly drive without eating, without fueling. If that's the case, how much of time do you need to drive? Well, you need to divide this distance by the speed of driving on average to get your initial drive time. So your drive time with no stop is going to be what? The distance divided by the speed, correct? That's the total drive time you need if everything is like more than ideal. But of course, most probably you need to fill the gas tank, especially if you're driving more than 300-400 miles. So now you have to consider that. And how do we do it? Well, you divide this distance, correct, by the gas mileage of your car, which says how many miles per gallon, correct, right? This is the total miles that you drive, and then you multiply these total miles by what? By, if you want to get the cost, you multiply that by the gas price, correct? This is the price of gallon of the car. So if you multiply this is going to be what? This is going to be the fuel cost, right? So this is the fuel cost, correct? Now, how many times do you have to stop for fueling? Well, you know that your fuel tank capacity is, let's say, 15 gallons, correct? For example. And the total gas that you need is this much in terms of gallons, right? So if you divide this number by the capacity of the fuel tank, that tells you how many times you have to fill the fuel tank. Now this number could have decimals. And if it's, like, say 2.3, then you cannot fill your gas tank 2.3 times. You have to fill it, you have to stop 3 times basically. So here I would use the ceiling command, okay, which gives you the larger integer number. And if you start with the filled tank, I take 1 times out of that to consider the number of what? The number of fueling. So the number of fueling times is going to be this much. Now here I need to make an assumption. How much time do you need per fueling, correct? So if you remember, I had one assumption that was 12 hours of, every 12 hours you have to sleep, and then every 5 hours you have to take a meal. But you have to have some other assumptions. For example, hotel time, which is the time that you sleep, or hotel stay if you want, right? Let's say just hotel time is how many hours should you add to your total travel time by road trip if you stay 1 night. So this is like 8, okay? So this is gonna be number of hours of stay at hotel per night, right? This is after how many hours you sleep at night in a hotel. This is gonna be after how many hours you need to eat a meal. You need the meal time, right? Let's say you need 45 minutes. Since it's in hours, you divide it by 60. So this is time needed per meal. And then you need the fueling time, right? Let's make sure that's not the same name. No. So the fueling time is going to be basically, let's say 15 minutes, right? So time needed per fueling. So if I need to stop these many times for fueling, and if each time it takes fueling this variable hours to fuel, then the total number of hours you need for fueling is going to be the product of the two, right? So if I multiply this by this number and then add it to the drive time that I had for no stop, this is going to be what? This is going to be the drive time with fueling, correct? So this is the drive time if the fueling is considered, and the cost that you had, this was the fuel cost. So right now your total cost is just the fuel cost, but now we have to go to the meal. So now this is the total time I need to drive with fueling. Now I need to divide this number by what? I need to divide this number by that number of hours I can drive before I need to eat again, and that is 5, correct? So I divide this to get what? To get eating numbers. How many times I have to eat? These many times. Correct? And now I can add an eating cost, which is going to be this eating number, correct, times the average cost of a meal, which is mentioned here, and the eating time, if I want to calculate, it is going to be this eating number, correct, that I calculated, times the average time per eating a meal, which is 45 minutes. So I need to multiply it by this. This is the total time I need for eating. And if I add that to whatever I had for driving with fuel, now this is going to be deriving with fuel and what? Meal. So this is my latest update of the total time, and my cost is going to be eating cost plus what? Fuel cost. But now the next level is to look at the hotel. So every 12 hours, I need to what? I need to sleep. So let's bring that in. So now this total new time that I have, fueling, driving, and meal, if I divide it by the sleep period, that is going to give me the number of nights that I will be on the way. By the way, here also, when I divided the drive time over the meal period, right, if it gives me a decimal number, I need to make it an integer because I cannot stop and eat 2.6 times. I have to either stop 2 times and eat or 3 times. And here I use the round command, not ceiling or floor. So if it's 2.6, it means I have to stop 3 times. If it's 2.2, I would stop 2 times. Okay, the same thing here. I use the round command to get me the number of sleep times, correct? So sleep number is equal to drive the latest total time I have by the sleep period. This is the number of times I have to sleep. And now this sleep number that I have, per each one of them, I have to what? I have to stay this much in the hotel. So I have to multiply that. This is the total stay in the hotel time. I added to the total time I had. And this is going to be driving with fuel, meal, and hotel. So this is my most accurate estimate of the total drive time, and I guess now I have used all of these 5 parameters in my calculations, as well as the price of the meal, the fuel. The only thing left is the hotel cost that we have to add, and we will do that. So this sleep number that I had, if I multiply that by the hotel cost per night, then this is going to be hotel cost, but I called the previous one also hotel cost. So this one I can call hotel cost. The previous one I can call hotel cost night, right? This one, because that's the total. This is per night. Okay, and now this, as I said, is my driving time total. So I can also call it, instead of with fuel, meal, and hotel, I can call it driving time total. And then the drive cost total is going to be sum of these costs. The hotel cost plus the eating cost plus the fuel cost. Okay, so this variable and this variable are the ones that I need to compare against this one and this one, and as well, of course, the total time left. So now that I have done my calculations, it is time to what? To make the decision. So here is the decision making. So I say if the flight time total is bigger than the time that you have left, you will display what? Flight is not an option since you don't have time for it. Okay, so if that's the case, that's what you show and say, hey, forget it, you're not gonna fly. By the way, here, as you can see, whenever I have double apostrophes, what's the meaning of that inside the text? Well, that's where you want to have the single apostrophe and say, what is your cars? But if I use one instead of two, it assumes that this one is the quotation mark at the end of the text, so it does not consider the rest of it as the part of the text, and that's why you get an error. So if there is an apostrophe in the middle of your text and you want to show that, use double, so MATLAB knows one of it is just an indicator that it's not the beginning or end of the text, and the other one is the actual apostrophe. Okay, and you can see that I have used it in several places. Then you do something very similar and you can say what? If the driving total time, right, which is this guy, drive time total, if the drive time total is bigger than the time left, then you say what? You say driving is not an option, right? Or here you can say flying is not an option because you don't have the time. So the decision is simple. You don't have time, you cannot make it, and you have to go there. So now, if what? If now the flight time is what? Is less than or equal the time left, which means you have the time of the flight to fly, and what? The drive time is more than the time left. Then again, it's a no-brainer, correct? Bigger than. So because you don't have time to drive, but the flight can make life possible. So all you need to display is what? Say, flight is your only option because driving takes more time than you have. End. Or you can use else if here and combine. Say else if. Else if it's the other way around. The flight time is too much, the drive time is not. This happens typically when the driving distance is not crazy and you might choose to fly, and actually all the commuting to airport and back and the connections and everything is gonna make the flight longer than drive time. It doesn't happen too often, but it might happen. So if the flight time is bigger, yet the drive time is less than or equal, correct, then you display something similar. You say, hey, the flying is not the option, right? You say driving is your only option because flight takes too much time or more time than you already have, correct? So far we have checked all the time conditions. Now it is the case that, well, else if both of them are what? Less than, correct? If both of them are less than, then what? So you can come here and say else if what? Both of them are in the acceptable range, then maybe now it boils down to what? The cost. If that is the case, then what? Then you look at the cost. So now you can add another if. You say if what? If the drive total cost is less than the flight total cost, correct? Then what? Then you display, hey, flight is cheaper. So say you can get there using both flying and driving, but flight is cheaper and it is suggested, correct? Else if, or else, because if the driving cost is equal to the flight cost, or what? If they are equal, that's a separate story, right? Because now both give you time, both give you what? Both give you the same cost, which is very unlikely to happen that the numbers are exactly the same. So I consider the case that the drive total is well, here it has to be bigger than, right? If the drive cost is bigger, then you say flying is the suggestion. If it's less than, then you say what? Then you say the driving is suggested. So you say you can get there using both flying and driving, but driving is cheaper and it is suggested. Else, which is, as I said, a very uncommon condition, else is because they are either bigger than each other, one is bigger than the other or less than. So else means if they are equal, then you say display both driving and flying need the same time and cost, so it is up to you, right? End. And then another end for the bigger if. So you see here you have an if-else-if case. That is your outer if, and then you have an inner if, right? So this is called nested if, right? And that's all you need. Can I combine the two top ifs with this bottom one? Sure, you can. What you can do is this. You say if the flight time is bigger than the time left, display that, and then what? It's over. Else if, right? Else if the condition is the other way around. The drive time is more than time left. You display what? The driving is not an option, and that's it. Else, which is the case that they are both in the acceptable range, now you can do what? Now you can come and make the decision on individual times, and then what? The costs. So first, let me do this. Correct? So here, with this big if, we are checking the times. And I can actually make this a combined else if like this. If one of them is the option, then do that. If the other one is the option, then do that. Right? And here I can say else. Else is the condition that, of course, then both of them are the option. Now, here I say, now let's look at the price. Correct? So this is now where you can do the right thing, look at the cost, the price, and can get rid of this like this. Correct? So you see the big if goes over time, and the smaller if, the inner if, basically goes over what? Over the cost, right? And so this is what you have, and here you see it is suggesting you to use the short circuit and, because that is the smarter end, and that can make the decision making faster. So if you want here, you can use the double end, or the what we call the short circuit end. Okay, no big deal. So now hopefully this code will work. Let's try it. So here we go. It says, how much time do you have to get to the venue? Let's say 22 hours. How long is the total flight time? Let's say I calculated based on some website, it's 14 hours. How much is the flight ticket? Let's say $850. What is the time you need to get to the airport next to you, and then from the destination airport to the venue? Let's say I need a 1 hour drive from here to airport. I need a 1 hour security time in the airport before flight, so 2 hours ahead of time. Then over there, half an hour, so 2.5. Enter the transportation cost. Let's say 2 rounds of taxis is about $120, or let's say $100. What is the driving distance to the destination? Let's say 950 miles. What is the average driving speed? 65. The gas price per gallon, $3. Your car's gas mileage is, let's say, 28. What is your car's fuel capacity tank? 15 gallons. The cost of hotel stay at night per night, let's say $90. What is the average meal price? $20. And you see here it says driving is not an option since you don't have time for it, right? Now, although it is really amazing that it gave me an option, it is a good idea that it shows the total what? The total time and cost of everything, right? So here it is showing you the final decision, but it is not really what? It is not really showing you the details. So when it says flying is not an option, I would also add a display here and say, or fprintf, right? And say the total flight time is, and then %42f, and then hours, correct? And here I put my total flight time here. So at least they know why it is not an option. You show them the number. Correct? And then I do something similar here when the driving is not an option. So I say the total drive time is so much, and then here I use the drive time total. Good. Now when here the flight is your only option, I can show both of them actually, right? So maybe here I say the total flight time is this many hours, or the total flight time and the drive time are, and then I say %for2f and %for2f hours respectively. And then here I add both of these variables. Good. And I can do the same thing for the other case too, where the driving is your only option. I would do the same thing. And finally, when it comes down to yes, they are both the option, but the cost, I would show what? I will show the cost probably. So I say because here it's I would show both at the cost. So I say the total flight cost and drive cost are, and then here I say dollars, and here instead of time I use the cost variable. And I can do a very similar thing for the other one. Okay, so it's always good to have an informative code. Now in this case, why did that happen? We can check, right? If we look at the flight time total, it is 16.5 hours. If we look at the drive time total, it is 25 hours, and the time left was 22 hours. So you are going to not be able to drive because your drive time is more than what is needed. And at the same time, I can also look at the costs. So the flight cost here is $9.50, but the drive cost is going to be $2.51. So you see, although the driving is much more economical in this case because it's not like a very, very short drive. At the same time, the drive is not crazy long, so driving is the good option. But because of missing the deadline by 3 hours, that's not an option. And you can play with this code and change the inputs, change the assumptions, and you can make it your own decision maker for whether you should drive or fly to a venue. So you can see that MATLAB coding can be used to solve real-life applications, and hopefully this video was useful to you. So see you in my next video. Thank you.